I'm Jordan Reisenhuber, and I'm the Education Coordinator for the NASA Oklahoma Space Grant Consortium. And you're right, you heard the word NASA, as in National Aeronautics and Space Administration. And you also heard Oklahoma Space Grant Consortium. Well, we, the Oklahoma Space Grant Consortium, are one of 52 space grant consortia, one in each of the 50 United States, one in D.C., and one in Puerto Rico, making 52 total. We're also, our state office for the Oklahoma Space Grant Consortium is located here on the OSU campus. And not only are we part of NASA, but we're also part of the College of Engineering, Architecture, and Technology. And right now, I'm actually coming to you on the campus of OSU in our STEM Engagement Center, which is where we do all of our educational programming with students and educators. So exciting. We're so glad to have you here today, STEM thinkers and doers. Well, as you know, for the last 3 weeks or the last 3 video sessions, we have been looking at rocketry. And we've been looking specifically at rocket fuel. We looked at trajectory. We looked at how weight affects how far a rocket will fly. And we looked at how fin design affects how a rocket flies. So now we're going to take a lot more look at just designing a rocket, engineering a rocket. But we're also going to look at the idea of protecting a payload. What's a payload? Well, a payload is anything on that rocket that you want to bring back safely. So that could be a person, it could be an experiment, whatever that might be. And today, we're going to start with what you may know as an egg drop. And so I've got 2 eggs up here. So if you're doing this with me at home, make sure you check with mom and dad first before you go and steal 2 eggs out of the refrigerator. But we're going to do 2 different, so we can see how 2 different devices work. We are going to take these eggs and we're going to make something inside this cup that will keep them safe when I drop them from as high as I can hold them up down to the ground. And so we're going to see how we can protect these payloads. So up here you'll see that I've got a variety of things. Not only do I have 2 eggs and 2 cups, which everything will have to, that I put inside here will have to fit inside the cup. Only tape can go outside of the cup. Then I have some scissors and duct tape, because every great experiment has scissors and duct tape. And then I also have a lot of different supplies that could vary based on what you have at your house. It's okay if you don't have these exact supplies. It's okay if you use different supplies. You may come up with something much more creative than I have up here. I basically just went into our supply closet and pulled things that I thought might work for my experiment. So I have cotton balls up here. I have balloons. I have cups, Dixie cups. I have packing paper, plastic bags, rubber bands. I even have some beans, some little, what are these? Navy beans. I have some little navy beans. Flexible straws. I've got some foam, and this is just foam pipe insulation, but it could be any type of foam. I also have these cut up little pieces of sponges, and I can't wait to see how they work. And I've got some felt and some napkins. I have these surgical pads that sometimes you get after surgery. So I have some of those that I think might work. So I'm gonna try to develop a device, 2 different ones that I think are gonna protect each of these eggs. So let's start with this first one. So for this first egg, I am going to need to think about how do I protect this egg. Okay, I know I want it to be soft inside, right? And I know I want it to be tight enough where my egg is not going to move too. So let me think about the things I could do. Well, I think I'm going to try starting with putting some of these sponges at the bottom. Now they are a little bit coarse because they're dry, so they're a little bit hard, but I still think they might provide some cushion for my egg. So I just have put some of those inside there. Okay, now that I've got those pieces in there, let me think what else might work. Let's see if I take a little piece of felt. And what if I wrap my egg up in this piece of felt? Like a nice felt blanket. Yes, my payload is getting nice and protected. So the next thing that I'm going to do is I'm going to stick this inside there, okay? Well, it can move around a lot. So what do I have in here that might help with its movement? What if I poured in some of these navy beans? So I'm going to pour these in around here because I think they might fill in little holes and gaps and might make it where my egg doesn't move around as much. Now, I'm a little worried that maybe I don't have enough softness in here. So, I am going to take my cotton balls, and I've got way too many. So, I'm going to have to take some of those out. So, if I smush this down and put tape across the top, then I can keep everything contained in my cup, which was one of my rules, remember, at the beginning, that it had to all be inside my cup. So, I am going to tape this down. So I've got one side taped down. Now I'm going to take this other piece of tape and I'm going to cut across and I'm going to tape it down. So now my egg is secure inside this cup. And I feel like I need to do one more across because I'm just a little worried. I've kind of got the edges are still open and it just makes me think I need to fix that. So let's do this. All right. So now we have it completely protected. All right. So the next thing that I'm going to do is I am going to take my second egg and I'm going to come up with a different way by which to protect it. So for this time, I'm going to take and I'm going to stuff napkins in the bottom, but I'm going to kind of create a well in which I can fit my egg in there. So that's going to make it a little bit, oh, but I can't go slow enough with my egg. So I think I'm going to need to take out some of those napkins, and we'll try 3. I had 5. That may have been a little bit of an overkill. And now I can get that egg all the way in there. And then I'm thinking, let's see, I think I'll use some of this padding, and I'm just going to cut me a piece off like so, and I'm going to stick it in here. All right. So now I've got this over top, and it looks just like this. And next, I'm going to take some of this paper, because I think it might provide some padding. And we're going to see how well that works. Okay, so now this packing paper is on top, and I am ready to tape. I lost my duct tape there for a minute. It was right in front of me. And I'm going to take this duct tape, and I'm just going to tape a few pieces of tape and put it across the top. So one, just like so. And then I'm going to take a second one. So, just like so. And you know what? I really feel like I need another set of tape going across the other way. So let's take it across the other way. Okay, so now what I'm going to do is I'm going to take each of these eggs and I'm going to move this table towards you for just a minute so I have a little bit of floor space over here. And then I'm just going to toss these down into the ground and we're just going to see what happens if either of my eggs gets protected. All right, so let's see what happens. So we're going to open up this first one, and this first one was the one with the cotton balls on top. And we use the navy beans in there to protect it. And it looks like, oh my goodness, I think it might have actually protected that egg completely. So because I put enough padding around it and I made it tight enough where my egg couldn't move around in there, my egg was able to survive. So I found out a successful way to protect my payload. Well, let's see if I was successful this time. Let's see. Oh, okay. So I had my packing paper and the padding on the top and my napkin underneath, and oh my goodness, this egg survived too. How can that be? Well, I figured out just the right amount of padding and enough way to restrict that egg within it so it would not break. So now that I figured out a successful way to do this, now I do have to consider something. I didn't drop it from very high, did I? So if I was dropping it from even higher, it might not have the same results. So depending on the heights, it's going to also make a difference in what kind of padding or what kind of protection you're going to have to provide to your payload. So now we are going to build a 2-liter bottle rocket that we are going to launch this egg on. And actually, instead of a 2-liter bottle rocket, we're actually going to use a 1-liter bottle rocket. But you can use a 2-liter bottle rocket for this. And you will need a 2-liter bottle rocket launcher. And at the end, we will reference a NASA website where you can find how to make your own 2-liter bottle rocket launcher. We're going to buy a store-bought one, which I'll talk about when we get to that part to launch ours. We use those just because they're super heavy duty for how many I launch a year, which is a bunch with all of the outreach we do when it's not usually COVID. And so those are 2 different options and ways that you could do a launcher. But the one that we're going to reference, it's really cheap, super easy to make. And NASA's done a great job of providing those plans so that you can do that in a cheap and inexpensive manner. So for this 2-liter bottle or 1-liter bottle rocket that we're going to be making today, so we've got to consider a few things. So my 1-liter bottle rocket is going to launch on a launcher. And that launcher looks just like this. Okay, this is actually a Pittsco launcher. And my table is not big enough for it to stand on, but if it could stand on, it would just stand up with its own legs. As you can see, there are, it attaches, mine I always use an air compressor with. I'm not going to put the air compressor up here, but an air compressor would be attached here. And then it attaches, that tubing attaches to a tube that will go up to my rocket. And my rocket is going to sit just like so on, let's see, let me show you really fast. So when I actually put my rocket on, it's going to look just like, it's not wanting to go down on it. But it's going to, that will go into that little stopper and it will set on my launch pad just like that. So that's going to give you an orientation idea of how your rocket is going to look on the launcher. So now that I know how that's going to work, and I know that air is part of my fuel, but something else is going to be part of our fuel. We're going to fill this up about halfway with water before we launch it. And then that way, the combination of the water and the air pressure is going to launch this rocket. How cool is that? So the first thing I've got to consider is, what is my objective with this project? Well, I have to get an egg to safely travel on this rocket. And so I'm going to have to think of how I'm going to protect my payload, just like I did with my devices up here. I'm also going to want to add some things. I may want to add a parachute as another payload protection device. I most certainly probably want nose cones, at least one nose cone, and fins on there. So we're going to design all of those ourselves as part of our rocket. So the first thing that we are going to do is, let's look at our fins. So we're going to go ahead and make those and get those over with. Now I'm going to be a little more creative than I have been on some of the other fins that we have made. And we are going to cut them just like so. Okay, so I've turned them into rectangles to start with. But what I'm going to do actually is I'm going to make kind of a interesting shape going up this direction. And this, for this one I'm using printer paper. You can use construction paper. You can use whatever kind of paper you have laying around the house. And I'm going to cut these just a little bit shorter because these are a little bit tall for our 1-liter bottle rocket. And so I'm going to take a piece of tape just like so. And I'm going to take this and I'm going to put it on my 2-liter bottle rocket. So now it's on just like that. But instead of just putting one piece of tape so that my fin sticks out just like I would like it to, I'm going to take another piece of tape and put that on the other side of that fin. That's going to stabilize that fin and make it where it doesn't flap around. And that's really important for our next step. So there we go. Now we've got one fin on there that looks just like this. Now we're going to go ahead and do our second fin. 2 more pieces of tape. And let's see. Get that across. All right. Then I'm going to take this and I'm going to put one on just like so. And I'm going to go on the other side and put it on just like so. So now I've got 2 fins on my rocket. I could put more fins on there if I wanted. Now something you're going to notice is I'm not putting anything below where this starts to curve smaller. That's really important because I don't want it to get caught up in my launcher. The next thing that I'm going to want to do is, as I'm thinking about the nose cone, I want to go ahead and think about how I'm going to protect my egg. And I actually kind of think might be the best thing is if I just turn this cup into my nose cone. And I think I'm actually going to use 2 cups to do it. I'm going to use one of these cups that I already used earlier. And then I'm going to use 2 cups, kind of this to help stop and this also to help stop, to kind of restrict my egg in there. So for this first part, I think what I'm going to do is I'm just going to take those cotton balls so that's nice and soft, and I've got too many in there because it's sticking out. So I'm just going to take those and I'm going to stick them all the way around in there. All right, so then the next thing that I'm going to do is I'm going to take a piece of tape and I'm going to put that across the top, just like so. So, let's see, it's not sticking, so I'm going to need more tape. I cut that way too short. And I've got another bigger piece of tape, and it's just like so. So my egg is now inside there. And then I'm going to take that and stick it inside of my other cup with some, it's got some felt around it. So I feel like it's pretty cushioned in there. And now I can attach it to the top of my rocket. And I'm going to allow that to be my nose cone. So for this part, what I'm going to do is I'm going to take some tape, just like so. And now I am taping that nose cone onto my rocket. And we taped it down just like this. So my rocket is on here just like this. So the next thing that I'm going to do is I am going to make my parachute. So for my parachute, I'm going to find one of these awesome plastic bags. And you don't have to put a parachute on there, but I am going to do that on mine because I feel like that might be a good design. So I'm just going to cut some plastic out of here. Now when you design your parachute, you may be more exact with how you design your parachute. I am just kind of cutting some pieces out and making me just a small little design for that. I'm then going to take this fishing line and I'm going to cut, don't need them too long because I don't want it to hang too far down off of my rocket. So I'm just going to take and put 1, 2, 3, and 4 strings. So now, with each of those strings, I'm going to attach it to one of my corners of my parachute. And so I've got one corner right here. Excellent. And so you can see I taped one corner on there. Now I'm going to go and I'm going to cut another one off for corner 2. And corner 3 and corner 4. So I'm going to make a little bit bigger cut this time. Okay, and then I'm going to cut that in half, just like so. There we go. And now I've got my third piece of fishing line on there. And I'm going to do one more. So I only taped one side of my fishing line for each of those 4 pieces of fishing line onto my parachute. Now I'm going to take these other 4 ends at the opposite end, and I'm going to put these all together, and then I am just going to tape these on top of my rocket. So just like, okay, let's see if I can get this off without making a mess. Okay. So, now, my parachute is taped to the top of my rocket. It also doesn't hang down too far because it doesn't go past where that part starts getting smaller. So I have a body tube, I have a nose cone, I have fins, and I have a parachute. And my rocket is ready to go. So we are ready to launch. And let's get ready to launch our bottle rockets.
You start it?
Yeah.
Don't look.
In 5, 4, 3, 2, 1.
Okay,
Let's go ahead and stop it.
All right, you ready?
Yeah.
5, 4, 3, 2, 1.
Oh my gosh!
Look at that! The cone was like.
Bye, Nemo! Oh!
My egg is just survived
Well, I hope you enjoyed those launches as much as I did today. Now today we used a 1 liter bottle. We learned how to make a 1 liter bottle rocket. We also learned how to protect a payload. Something also important to understand about this rocket you made, that rocket, just like some of the other rockets we've made, it's how high it goes is going to be dependent upon how much weight. Now, I will tell you that I have had 2 liter and 1 liter bottle rockets that were light enough that they went as high as a Model A rocket engine with my air compressor and launcher. How cool is that? And you might get the exact same results. So consider weight, consider design. Remember when we talked about fin design and we saw in our foam rockets how fin design affected our rocket? Well, it's going to affect this 2 liter bottle rocket too, isn't it? And I hope you saw in all those different rockets, the different designs, how they each flew differently and to different heights and in different ways. It's just really cool. And some of them went off so fast it was really hard to tell much, wasn't it? Yes. So we've learned a lot with our rocketry lessons. And that is part of the Artemis mission and getting us back to the moon, NASA's Artemis mission. If you want more information on the rocketry side, please go to nasa.gov and check out their Moon to Mars portion of that site. It is fantastic. It's got great lessons and great things to do at home as a family. It also has links to the latest information of what's going on with our Artemis missions and how you can get involved in the public. And there are so many different ways by which you can do that. So please check that out. Check out this inexpensive way to create your own water bottle rocket launcher for your home and or school using a simple plan designed by the NASA Office of STEM Engagement. This is a fantastic way to inexpensively bring this launcher into your classroom. The only change is that instead of an air compressor, you would have to use a bicycle pump with this design. Be sure to check it out and design one at your home. For any questions, please feel free to contact our NASA OKSG STEM Engagement Center for Bryce's expert advice on building this particular launcher. We hope you try it out soon. Until we see you next time, race it to the moon.